just over 10,000 years ago, huge woolly mammoths, woolly rhinos, giant ground sloths, dire wolves, and even giant armadillos roamed the land. And now they're gone. So where did they go? In this video, I'm going to talk about the evolution and extinction of these giant megafauna that lived in the Pleistocene epoch from about 2.6 million years ago until about 11,700 years ago. And I'll talk about some major examples of these megafauna, like those I just mentioned, as well as what we think made them disappear. So first, what are the megafauna? Well, megafauna just refers to kind of huge animals, and typically when we're talking about the Pleistocene megafauna, we're talking about huge animals that roamed Earth during the Pleistocene epoch, which was the one just before our current Holocene epoch, which, like I said, went from 2.6 million years ago till about 11,000 years ago. And from what I've seen, the size requirement or criteria to be classified as megafauna is that the animal just has to be over 45 kilograms or about 100 pounds. So yeah, we're technically megafauna, I guess, of the Holocene, which is pretty funny. Well, I guess not our babies, but our adults. But I guess that's not true of any babies. Okay, I'm getting off topic. Anyway, what I want to answer in this video is kind of what were they, where'd they live, how'd they live, and why and how did they go extinct. So first, to set the scene, the Pleistocene epoch is known for, well, being an ice age, the most recent ice age, with very distinctive interglacial cycles. What this means is just repeated up and down fluctuations in temperature due to repeated periodic changes in Earth's astronomical cycle. So it's orbit, it's wobble, it's tilt. And so because these astronomical factors of Earth change periodically on a, predictable periodicity, it was cyclic change up and down. And essentially what's important to note about the Pleistocene Ice Age is that the Ice Age is kind of the whole time period that these interglacials have been going on. So from around 2.6 million years ago to today, really. But this last cool period, or the last time that glaciers were at a maximum, is what we call the last glacial maximum, or LGM. So if you see LGM throughout this, video, that's what that means. Essentially, right after the LGM, we started seeing warming in this Bulling-Aylward event. Sorry if I'm mispronouncing that. And this was the beginning of interglacial warming, coming out of the cool cycle, moving into the warmer cycle, which eventually led us into our current epoch, the Holocene. But what's interesting about this interglacial warming is it started to warm and then it dropped dramatically in this rapid cooling event that we call the Younger Dryas cooling. The Younger Dryas is just named for plant, a flower, I think, something Dryas, or Dryas is the genus, I don't know. Anyway, it just marked colder conditions, colder climates, because that flower likes to live in colder climates. It doesn't necessarily mean that conditions were drier. The dry part of that word, don't read too much into that. But things got cooler during this Younger Dryas time frame or cooling event. And this Younger Dryas is the time frame within which the megafauna went extinct, or most of them. So was this rapid cooling event the cause of their extinction? Maybe, but maybe not. As hinted by this picture, human overhunting may have played a role, but I'll get into the caveats with both of those hypotheses later in the video and suggest some other hypotheses that people have also proposed and kind of the evidence and lack thereof for all of these things. First, though, let's talk about what the megafauna were, some major examples at least, and where they lived, how they evolved, stuff like that. Megafauna at this time included a variety of mammals much larger than those today. Well, some of them larger than those today, some of them kind of similar sizes. In any case, they were, remarkable for their huge sizes. Notable examples include mammoths and mastodons, as, in these pictures, as well as on my hat, which, I had to wear this hat for this video. Saber-toothed cats, sometimes called saber-toothed tigers, but they're not tigers. They were big cats, but not tigers necessarily. But these guys are also really, popular. Pretty much picture the Ice Age movies and, we've got the megafauna. Giant ground sloths, obviously Sid, of course, but probably a little bigger. Giant ground sloths were freaking huge. Megatherium's the genus name. We'll talk about that later. Giant armadillos or Glyptodon, again, the genus. These guys are, I think, my favorite. Who knew there were giant armadillos? These are also in Ice Age. I looked that up. They were minor characters. I wish they were bigger. The giant short-faced bears, woolly rhinos, which, I think should have been a bigger thing. I didn't even know about woolly rhinos till researching for this video, so let's make that more known. That's like one, adorable, also terrifying, but really cool. And the dire wolves, which I've always known for obviously the Pleistocene. I didn't know, however, that they were also a fictional thing associated with Game of Thrones or something. I don't know. I haven't watched it. I know. I don't like to commit to very long series because then I spend too much time binging things. Anyway, I don't know if you guys know of this thing, but they were real. They lived in the Pleistocene. So yeah, or at least I don't know if the fictional thing was based on the real one or not. But anyway, they were real. But anyway, let's take a minute with each of these groups and kind of go through how they got to where they were and how they lived. So first, starting with mammoths and kind of elephants in general. The earliest known proboscid, or the order of elephants, the big group that includes elephants, mammoths, etc., was this kind of small pig-sized herbivore in Africa around 60 million years ago. So long before the Pleistocene, kind of right after the KPG extinction event that took out the dinosaurs, allowing mammals to start growing larger, diversifying, etc. Then much later, around 37 to 30 million years ago, came Phiomia and Moeritherium. I'm going to go with that, which are two genuses that lived in northern African swamps and woodlands. And the Moeritherium had a flexible upper lip and extended canines that may have been rudimentary tusks. But they spent most of their time half submerged in water like hippos, or more like hippos at least than elephants, whereas Phiomia were more elephant-like, weighing half a ton and eating terrestrial rather than marine vegetation. Finally, Gomphotheres appeared around 28 to 30 million years ago. And this group is the one that eventually broke out and led to mastodons, mammoths, and eventually modern elephants. They were widespread across lowlands of North America, Africa, and Eurasia from around 15 to 5 million years ago. And yes, modern elephants and mammoths did coexist. It's not that modern elephants evolved from mammoths, which, I probably should have known that. Didn't know that. I just kind of assumed, mammoths, then elephants, whatever. But actually, they both had a common ancestor that kind of broke off into each group. And it's just that elephants survived to the present and mammoths did not. Mammoths and mastodons are Pleistocene megafauna examples, evolved from Gomphotheres around 23 million years ago for mastodons, so a little bit older of an origin for mastodons, and 6 million years ago for mammoths, so relatively more recent as shown in this timeline. Then they both went extinct at the end of the Pleistocene from around 12 to 10,000 years ago during that Younger Dryas time. I do have this range here rather than a specific year that they went extinct because, and you'll see this throughout the video with other megafauna as well, because one, these extinctions were relatively protracted both spatially and temporally. Some species went extinct in this region at this time, then others went extinct at this region in this time. Overall, the extinctions took place during the Younger Dryas, and all the megafauna, the major groups, were extinct by the end of the Pleistocene. However, it was kind of over time and in different places at different times, which, later we'll talk about what that means in terms of causes. But in any case, this is one reason that I don't have a specific year here. Also, another thing to keep in mind, because I make a lot of videos about mass extinction events, in other videos when I talk about, everything went extinct around 250 million years ago. I don't have a range there because when it comes to 250 million years ago, we're talking over a range of, plus or minus 1 to 5 million years, depending on the extinction event. Some extinction events lasted over 10 million years. So it depends on the extinction event, but they don't happen in one day. So remember that when I say 12 to 10,000 years ago, that range seems like a long time, but it's relatively rapid for mass extinctions. So anyway, that's why it's a range, not one particular year. Also, notice that there is a dotted line on the mammoth timeline over here on my geologic time scale of when these things lived. That's because mammoths largely went extinct at the Younger Dryas by the end of the Pleistocene. However, some continued into the Holocene, as we figured out later, isolated on a specific island, and they actually became small because of this isolation. Anyway, I won't get into this now. I think I talked about this in one of my videos. If I remember which one that is, I'll link it to the top right. But I might make a whole future video about those. So anyway, that's just one group that only survived because they were isolated on this island. For the most part, on most major continents, mammoths were effectively extinct by the end of the Pleistocene. Why? Well, we think it was mainly due to human hunting. Again, this also, makes more sense with the relative protracted nature of these extinctions. Humans arrived over here, blank went extinct. Humans then arrived over here, blank went extinct. This kind of pattern that we see in the rock record. But I'll talk more about that later and kind of the caveats with that. Now moving to Smilodon, the genus of saber-toothed cats that we love so much. These massive, terrifying predators with terrifying teeth belong to the extinct subfamily Machaerodontidae. I don't know if anybody actually knows how to pronounce these. Anyway, this subfamily lived from the Neogene, right before the Pleistocene, till the end of the Pleistocene when the genus Smilodon went extinct. And based on their fossil records, saber-toothed cats were more robustly built than any extant or living cats, with well-developed forelimbs and obviously their exceptionally long upper canine teeth. The largest species got up to about 450 kilograms or 1,000 pounds. They hunted large herbivores like bison and camels, very similar, I think, to lions and other big cats today, and they likely lived in closed habitats like forests or bush with cover for ambushing prey. From what I've read, we don't actually quite know yet whether they lived and hunted more in prides like lions or were more solitary like tigers. We're not actually quite sure, and I don't know if we'll ever figure that out fully, but obviously there's ways of looking at the fossil record to see whether they were grouped or not, but maybe we'll figure that out at some point. In any case, Smilodon died out with most of the other American megafauna around 12,000 to 10,000 years ago, like we talked about with mammoths and mastodons, and likely their extinction, rather than due to overhunting, was likely due to the loss of their prey due to human overhunting their prey, as well as climatic changes associated with the Younger Dryas cooling. So their extinction was probably due to both climate and human activity. Next, we have giant ground sloths, or the genus Megatherium. Megatherium is such a good name for such a huge megafauna. Anyway, these guys lived in South America from around 5 million years ago, so a bit before the Pleistocene, up until the end of the Pleistocene. And the extinctions of Megatherium coincided with that of other mammal megafauna, which followed the first arrival of humans in the Americas. Therefore, hunting likely played a role in their extinction as well. Next, we have Glyptodon, the giant armadillo. These guys lived from about 5.3 million years ago till around the end of the Pleistocene. They were part of a subfamily, Glyptodonts, which lived from all the way back into the Paleogene up until their last genus, the Glyptodon, went extinct. And these are my favorite because they're so impressive in terms of their size. They got up to 3.3 meters or 11 feet long and 2,000 kilograms or almost 4,500 pounds, which is absolutely insane. Glyptodon was one of many South American megafauna that got to insane sizes like the giant ground sloths that we just talked about, Megatherium, as well as Notungulates, which are an extinct group of ungulates that lived during the Pleistocene, also classified as megafauna, but I didn't list any notable examples just because they don't really have any like living relatives that resemble them that well. They're kind of like, I don't know, giant camels. I don't know, but really insane. And Glyptodon, in terms of how it lived, what it ate a mixed diet of grasses and other plants. And their armor protected them from predators like Smilodon, our saber-toothed cats, Protocyon, large canids, Arctotherium, which were Central and South American short-faced bears. There were other short-faced bears in other regions that I'll talk about in a couple slides. And obviously, humans. And like we have seen with all of the other megafauna, Glyptodon went extinct at the end of the Pleistocene around 12,000 to 10,000 years ago. Moving to the short-faced bears, we had Arctodus, the largest genus of these bears that evolved around 2.5 million years ago and got up to 3.4 meters or 11 feet tall on their hind legs and about 1,000 kilograms or 2,000 pounds. These bears lived in temperate open woodlands of North America and hunted herbivores such as deer, camelids, and tapir. And like all the other megafauna, they went extinct at the end of the Pleistocene around 12 to 10,000 years ago, likely due to a mixture of things. 1, climate. 2, probably some loss of prey from human hunting. And 3, competition with modern bears. Next, we have woolly rhinos, which are an extinct species of rhino that lived in northern Eurasia from about 1.8 million years ago, so kind of in the middle of the Pleistocene until about 14,000 years ago, and I'll get to why that's not at the end of the Pleistocene in a second. They fed mainly on herbaceous plants, and their long, thick hair, like the woolly mammoths, allowed them to survive in extreme cold, harsh mammoth steppe conditions. The mammoth steppe, by the way, if you don't know, is just kind of an environment or ecosystem that was characterized by the environments that mammoths both lived in and maintain. Mammoths kind of had this unique ability, as well as other megafauna, to clear, forests and shrublands and create and maintain these grasslands by trampling down trees and keeping things trampled and smashed down so that grass could grow, and then grazers would come and live in this ecosystem, and everything would kind of, create this grassland ecosystem that was called the mammoth steppe. So that's what this is referring to. Importantly, the woolly rhinos, unlike many other megafauna, went extinct around 14,000 years ago, likely due to the brief rapid warming event that we talked about earlier, which occurred just before the Younger Dryas. This was the interglacial warming from around 14,000 to around 12.9 thousand years ago, just before the Younger Dryas. Cooling that occurred from around 12.9 thousand years ago to 11.7 thousand years ago, which marked the Younger Dryas period. This warming would have caused increased precipitation and snowfall, which transformed their low-growing grass and herb habitat into shrubs and trees. And this just, restricted their livable habitat until they went extinct. However, it's important to note that this warming event, which precedes the Younger Dryas, which then marks the period that most of the megafauna went extinct, may have played a role in other megafauna extinctions as well. For example, the dire wolf, a large extinct canine, is thought to have become very restricted in range around 13,000 years ago, nearing the end of that warming event, and then gone extinct right after in the end of the Pleistocene during the Younger Dryas. So it's likely that the warming was the first kind of thing that may have restricted the ranges of these megafauna, given their adaptations to cold climates. And then once colder conditions came back during the Younger Dryas, the cooling was relatively rapid, so that was difficult because they had all just migrated to cooler climatic ranges due to the warming event, that then when the rapid cooling came, it would have been really devastating if they couldn't handle that cold of conditions. And 2, by the time the cooling came and they could expand again in range, humans had by then taken over a lot of the regions they used to roam, and obviously as they were walking right into the now human inhabited environments, they were walking right into their predator's home. So we've talked about climate and human hunting and competition with other modern species as causes for these extinctions, but what exactly caused the extinctions of each of these groups specifically? Well, one thing you may have noticed going through these different species or genera on this list of megafauna is that most of these were large herbivorous mammals that lived in the Americas. Well, the timing of human arrival in the Americas coincides pretty nicely with the extinctions of these American megafauna. So that leads one to believe that at least some of these groups were likely, if not, totally extinguished by, at least restricted by, the overhunting of their individuals by humans. So for mammoths and mastodons, it was likely a mixture of both rapid climate change and hunting and or other human activities. Remember, hunting is not the only thing that likely led to them becoming restricted and killed off. Also, we introduce diseases, new types of diseases, invasive species, habitat alteration, fragmentation, and destruction. We use up a lot of land. We change the way that it's used, the way that it's fragmented, the way that it's distributed, what's growing there, etc. So a lot of these human activities, not just hunting, is kind of wrapped up in this one idea of like the overhunting hypothesis, but really it's all these human things that we do, not just hunting. And then for groups like Smilodon, the saber-toothed cats, it was likely mostly loss of prey from both climate change and hunting. For giant ground sloths, it was probably both climate change and hunting and all the other human things. Same thing with giant armadillos, our friend the Glyptodon. And then loss of prey, climate change, and competition with modern bear species for the giant short-faced bears. Woolly rhinos are unique, and then it was probably mainly climate change because their extinction preceded the Younger Dryas. It was during that warming event just before. At least based on our current fossil record of these species, they may have continued on into the Younger Dryas, but it seems that they were at least extremely restricted by the beginning of the Younger Dryas due to the warming. And then the dire wolf, like saber-toothed cats and bears, was probably loss of prey, climate change, and competition. So if we want to invoke the Younger Dryas, climate change, or rapid cooling as one of these extinction causes, what actually caused this rapid cooling event? What caused us to go from this interglacial warming, drop back into cooling, and then back into interglacial warming? Why didn't the interglacial keep warming? Well, there are hypotheses for what caused the cooling, anywhere from meteor impacts to volcanism to a shutdown of the ocean conveyor or circulation belt. But I talk about that in my next video over the Younger Dryas cooling and what caused it. It may be out by the time you're watching it, but if it's not yet, or if it's members only, it will eventually be out for everybody, so don't worry about that. Just wait a couple of weeks. But before you go, if you are interested in megafauna or any life that was mega-sized, you probably also love dinosaurs. And on my channel, I love to educate about dinosaurs. But instead of just listening to a lecture or reading a book, you might want to learn in a more fun, engaging kind of way. And I happen to know about a really, really exciting game coming out called Dino Survival. The creator of this game, David Hills, has worked really hard to make this game not just random dino facts, but really educate on how these dinosaurs lived in terms of their environment and their diet. And it really kind of connects all the dinosaur species together and how they lived in ecosystems relying on one another, which I find really, really fun. So far, the final version of this card game is not officially out yet for purchase. However, you can support the Kickstarter for this game right now at the link in my pinned comment below, or I'll also put it in the description for this video. And if you do support the Kickstarter, you can get a 25% off the game with guaranteed fulfillment after successful Kickstarter. So I highly encourage you to go check that out. I've played the early version or the pre-print version of the game. It's really fun. And David has been really accepting of my feedback and has made all the changes that I've suggested. So I highly recommend. Great game and great creator. Amazing thing to support. If you have kids that love dinosaurs, highly recommend. It's like any age I feel like can enjoy this game. So yeah, go check that out. And with that, I will see you guys in the next video. Bye.